Alright, solving a system of inequalities. Now, in order to solve a system of inequalities, there's a few steps, just like solving a system of equations, basically the same steps. First thing we want to do is we want to make sure our inequalities are in slope-intercept form. So we want to make sure that they're in slope-intercept form so they're very easy to graph. So once we have that, we check that. Then the second thing is we're going to graph our equations. And then after we graph the equations, or graph the inequalities actually, you graph them just like their equations, we have to shade in our graph. So we're going to shade above the graph or we're going to shade below the graph. And then the last thing is our solution is the double shaded area. So our solution is a double shaded area of our graph. So if we look at the first example, so we have y is greater or equal to 1x plus 2 and y is less than or equal to negative 2x plus 4. They're both in slope-intercept form. So what we're going to do is we're going to graph the first equation. So we want to start this equation at 2. Alright, that's our y-intercept, so we start at 2, so it's up 2. And then the slope is 1, so we're going to say our slope is 1 over 1, so we go up 1, right 1. And we're just going to continue going up 1 and right 1. And we can also, instead of going up 1, right 1, we can go down 1 and left 1. So we're going to extend our graph. And now when we notice it says y is greater than or equal to that, or equal to means this is going to be a solid line. So now we have this first equation graphed. Alright, so this is y is greater than or equal to 1x plus 2. Now I'm going to change my color so I can distinguish between the two different graphs. So now we have the second graph, which is y is less than or equal to negative 2x plus 4. So we start this one at the y-intercept, which is 4. So 1, 2, count up 4. Now we have a slope of negative 2. So it's down 2 and right 1. So our slope, negative 2 over 1, down 2, right 1. And we're just going to continue to do down 2 and right 1, down 2 and right 1. Or instead of going down 2 and right 1, we can go up 2 and left 1. And since it's y is less than or equal to, that equal to means this is a solid line. So we can connect all of our points. And this is the graph of y is less than or equal to negative 2x plus 4. Now we can go back and it says to shade in the graph. So we want to shade in. This sign means greater than or equal to. So greater than means we want to shade above this graph. So I'm going to shade above the graph. So everything above this graph I'm going to shade in. So anything above the graph represents a solution. So anything that shaded region, that red area, is a solution. And then the second graph, this sign means less than or equal to. So what we're going to do here is we're going to shade below the graph. So we look at this line, and we are going to shade below this line. So everything below this line. And now once we start to do that, what happens is this area gets double shaded. So we shaded, and now we're double shaded. And anything in that double shaded area, that represents the solution to the system of inequalities. So I'm just going to highlight that in this black part. That's everything right in this area in here. So this is the double shaded region. So anything in that double shaded region is the solution. Right? The red part up top, that's a solution to above it, and the blue part is a solution to below. But the double shaded area represents the solution to this system of inequalities. So if we look at the second example, we're going to continue. We're going to check the graphs. They're both in slope-intercept form, so we can graph them. The first one, we start at negative 5, and the slope is 1/2, so we go up 1. Slope is 1/2, so we go up 1 and right 2. And we can go down 1 and left 2. So we are going to put our points on. And now when we look at this, it just says y is less than. So since y is less than, that means our graph is open. So we have an open graph or we have a dashed graph. Since it's not equal to those points, they're not part of the solution set, so we leave breaks inside the graph. Now we can graph the second equation. So we start this one at -5 also, so it has the same y-intercept, but this time the slope is -1/2. So -1 means to go down, 2 means to go right, so we're going to go down 1 and right 2, down 1 and right 2. Or we can go up 1 and left 2. So we're just going to plot all of our points, and then once again it says y is greater than. So since it's y is greater than, that means we are going to have an open line or a dashed line. So we're going to leave spaces in between all of the points so that it represents that it is an open line. And this is the line y is greater than -1/2 x minus 5. And this is the line y is less than 1/2 x minus 5. So since we have less than, we know that less than means it's below, so we're going to shade below this graph. So everything below this graph is a solution. And then I'm going to change the color back around so you can distinguish between each one. This sign means greater than. So since this is y is greater than -1/2 x minus 5, we want to shade above. So everything above this graph is a solution to it. And then our solution to the system is this double shaded region. So everything in that double shaded region is a solution. So once again, I'll highlight that in black here. So this whole area is a solution to our system of inequalities. So everything in that little area is our solution. So any point in there will work for both of these equations. And then if we look at the third example, now with this one, it says make sure that they're in slope-intercept form. Well, these two equations are not, so we have to write them in slope-intercept form. Well, that means we want y by itself, so we have to get rid of that 2x. So we subtract 2x from both sides. Now I'm going to bring down the -y, so it's -y is greater or equal to -2x plus 1. Then the next thing we do is we have to get rid of that negative, so we divide by -1. And now whenever we divide by a negative, we know we have to flip this inequality sign, so we have to flip this. So it's going to be y, it's going to flip, so it's going to be y is less than or equal to 2x minus 1. So now we have our first equation. So now we can graph this equation. So once again, we start at the y-intercept, which is -1. And we have a slope of 2, so up 2 and right 1, up 2 and right 1. So we're going to continue going up 2 and right 1, or we can go down 2 and left 1. And now we check this, and this is a less than, or equal to. So that means it's going to be a solid line. We're going to connect all of our points. We have a solid line, and that's the first equation. So now we can go back to the second equation. So we have 3x plus y is less than -6. We know it's not in slope-intercept form, so we have to write it in slope-intercept form. So we have to get rid of that 3x first. So we do minus 3x, minus 3x. I bring down my y, so y is less, so I'm going to write my x first. -3x minus 6. And since y is by itself, we're done. So now we can graph the second equation. So we have y is less than -3x minus 6. So we start at the y-intercept, which is -6. And now we have a slope of -3. So the slope of -3 over 1 means we go down 3 and right 1. Or instead of going down 3 and right 1, we can go up 3 and left 1. Now this symbol has just a less than. So it's just less than, so that means we have an open line or we have a dashed line. So I'm going to put my arrows on the end and then put my dashes in between these. And so now I have a dashed line or an open line. And I know that this is the equation y is less than negative 3x minus 6. And this one is y is less than or equal to 2x minus 1. Well, since we know it's less than means we shade below. So I'm going to shade everything below this first line. And then we also have another less than. So we have another less than, so we shade below this line. So I'm going to shade everything below the second line. And I shade, and now I'm going to double shade. So everything that's in this double shaded area represents our solution to the system of inequalities. So I'll highlight this in black again. So this area right in here represents our solution to our system of inequalities. And that's how we graph our inequalities to find our double shaded region, which is our system of inequalities.